What's this? All right, so we have Lisa and Yvette here. Anyone else? No, I only have 2 viewers right. This is the thing where I could screen. Yeah, still just 2. I was trying to stream what was on my screen using OBS, but for whatever reason, YouTube keeps blocking my OBS, which is really annoying. I could just do it on Twitch, but you guys have to go through the hassle of making a Twitch account to talk to me, and 2, I don't want you guys knowing my personal Twitch streaming channel because that'd be really awkward. So yeah. We're just gonna have to go old school because I have looked through every single classroom down here in Doheny, and none of the podiums, at least the classrooms that are unlocked, are working. Touchscreen to work with. Thankfully, I found a classroom with markers in it, so I'm just gonna have to go old school. Can you guys hear me okay? Little you cut out sometimes. Great. Okay. If I hold the mic like this, will it sound better? I'm an announcer now. We It's gonna sound like that the entire time now. Okay, so I guess it's just gonna be just us chickens showing up because there's only 2 viewers and a me. I don't know. I'll give it like another 2 minutes. See if anyone else shows up. Unless you guys already have questions that you want me to start answering. Hi, Yvette. I didn't care what to ask. Hola mujer. Oh, racist. No, I'm just kidding. What chapters are going to be on the final? For sure, we're going to have chapters 10, 12. Those 2 for sure, because they intertwine with each other. I don't remember if momentum was on there. Was there any work? Any collisions? Probably. Momentum's probably going to be on there. So chapter 8, equilibrium and elasticity, we're going to have to be focusing more on the force of a spring. Don't worry about torque because we have not covered that. We're going to have to worry about frictional force. Then we also have momentum, which is chapter 9, conservation of momentum, whether it's elastic or inelastic, and impulse, that's going to be on there. We also have chapter 10, energy and work. So how energy is converted within a system. It's the whole conservation of energy, how it cannot be created or destroyed, blah, 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 that whole ordeal. Then we go into thermal energy. What is heat versus temperature? That's going to be on there. Energy in collisions. So more than likely you're going to have a problem like that where she's going to relate learned about energy with everything that you learned about momentum. So make sure you take a look at that. The conservation of energy and the conservation of momentum. Power is going to be on there for sure. Ideal gas law will probably be on there. Probably not, because those are pretty easy problems. Thermal expansion we did not cover, so don't worry about that one. We have phase changes and calculating heat. So our MCAP equation and our MILF and MILV equation. Calorimetry will probably be on there because that's pretty much what the quiz was. And that's pretty much it since we did not make it into fluids. So don't worry about that. Are there any questions on those concepts? Hi, Arlene. Welcome. Yeah, basically chapters 8 through 12. I saw we had a fourth viewer, but I guess they left. So basically what you missed out on, Arlene, is that what chapters are going to be covered in the final exam. Like if it said basically chapters 8 through 12. Can you start with chapter 8? What do you want me to start with chapter 8? Chapter 8 is equilibrium and elasticity, so anything having to do with springs and friction. Trying to keep something at static equilibrium. No, inelastic versus elastic is chapter 9, so that's referring to like when things collide within so momentum, and if it's inelastic, they stick together, and then if it's elastic, they kind of separate. So see if this works. Can you see that? No, you cannot. Okay, hold on. It's about to be a bumpy ride. Better? Was it backwards for you guys? So I have to write everything backwards. Oh, it's backwards. Hey. Like that? Can you read that? Do it right now. No, it was normal. Oh, awkward. Hey, it looks normal on my screen. So inelastic collisions, remember, was a whole M1 V1 plus M2 V2 is equal to M3 V3. So this is chapter 9. This is momentum. And then you have elastic, which is basically M1 V1 plus M2 V2 equal to M1 V1, etc. And that's initial, that's final. Can you? Because all I really have my supplemental. Yeah, that's momentum. There's a specific question you guys have in mind? What about the quiz for chapter 8? Okay. So like your guys' quiz? I can do that. Go over your quiz, have it figured out. So it says when a 14 kilogram mass hangs from a spring that has a constant of 550 newtons over meters, the spring has a length of 82 centimeters. Draw a free body diagram of the spring. That's the first part. It doesn't say whether it's vertical or horizontal, so I'm just going to go horizontal. There is a 14 kilogram mass. We know that K is equal to 550. And we know X is equal to 82 centimeters, which I know we're going to have to convert later. Oh, on this exam. Yeah, springs are on this exam. Springs and friction. Because those weren't covered in your midterm. Draw a free body diagram. Oh, it says it hangs. Never mind. It's on the y-axis. I can't read apparently. Again. Free body diagram. Oh, goodness. I need more hands for this. Maybe like a headset. Just be like, hello, welcome. No, I'm breathing too much. Anyway. So there's that. You're going to have weight pulling it down. Can you see the pink? No, not really. Oh, that's stupid. Hold on, can you? No, not really. Fudge. I mean, I can go raid other classrooms, see if I can steal more markers. Anyway. I'm getting weird looks from the janitors. Okay, so we have And then to neglect weight, we have the force of the spring, so FSP working on it, working against it. We know it's not moving left or right, so we don't need to worry about any of those kind of forces. So I think that we're pretty much good when it comes to that. Determine the length of the speed of the spring before any force is applied to it. The length of xi. So when there is no object. Does anyone remember the equation for this one? Hi, Giselle. FSP equals delta x. Eileen, that you were cussing me out. Like, I guess because it sees FK, it thinks that you're saying the F word. Anyway. Turn the length of the spring before any forces are applied to it. Anyway, so does for this one, I was gonna ask you guys, does anyone have any idea how to do this? But you guys are online, and it'd be kind of hard, and it'd take us a long time for me to actually get a response. Do it right to it. Anyway, so I know that here that down is gonna be 0, right? So that means that FSP is gonna be equal and opposite to my weight. Remember that from chapter 4? So if I want to find a value for FSP, I'm going to have to solve for weight. How do I solve for weight? Can you see over here? Yes, you can. W is equal to mg. Weight is relative to the mass or the inertia of an object times gravity, which is an acceleration due to the planet that we live on. Remember that? Oh, good times. Anyway, I want to know. Anyway, 14 kilograms. That's kg times 9.8 per second squared. And I don't have my calculator on me, so can any of you guys be oh so kind as to multiplying those two together and tell me what you get? And 37.2. We good? Everyone get that? I'm going to assume that it is correct and keep going. So I know that, so it's going to have to go back over here. And in this situation, we do consider the negative because it's equal and opposite to it, right? So negative 137.2 newtons is equal to negative K, which is 550. I should have done this lower. Negative 137.2 newtons is equal to negative 550 newtons over meters. And then our change in x is equal to the final minus the initial, which we know the final is 82 centimeters, so we got to bounce that 2 times. So it'd be 0.82 meters. Tell me if I'm messing something up, okay? Minus your xi, which you do not know. And then from here, you just use basic algebra to help you solve for xi. Distribute the thingy. I don't know what that is. Then you get negative 137.2 newtons, negative 550 newtons over meters times, that becomes a positive because xi is negative. And then this becomes a negative. Let me see with my calculator. $550 times 82. I got 451 for that one. 451. That cancels out the m, so that just makes it newtons. Wait a minute. I have an issue. Oh, thank you, Arlene. I have an issue. Can anyone see it? If I were to continue through with this problem, what would happen to my xi? Would it be positive or negative? Oh no, wait, never mind. We're fine. Would it be negative? Now I don't know. Let me try it. 137.2. That's negative. Hold on. I don't think I can do negative on this calculator. 137.2 times minus 1. There we go. And then add 451. Oh no, we're fine. We are fine. It'd be positive. We're okay. I freaked out for a bit. So, in case anyone doesn't really follow my algebra here, plus 451 newtons. You really can't see it. Yeah, there's a decimal there. Sorry about that. From Canada, eh? And yeah, you really cannot see that. Can I do it over here? I can do it over here. So then we get 313.8 newtons, which is equal to 550 newtons over meters xi. And then you just solve for xi. Divide it. I got 0.57. So this was the size before it had a mass attached to it. Can you guys see it? Like, I know I have a really crappy camera, and the lighting in here is not the best. Yeah, that's what I thought. You cannot see it. Let me try getting you guys closer. That better? Can you see everything? Yeah, I kind of like this better. I'm gonna do this. Can you see with your special eyes? Hi, Brad. Did it freeze? Hey, so we okay with this answer? Hello, welcome to ASMR with Yaya. Oh, it's all good. But are we good with this problem? Okay, we good. Giselle's good at least. Uh, this was a pretty simple problem, pretty straightforward. It's a nice refresher as to what springs were all about. The second problem I know gave a lot of you guys issues. Do you want me to go over it? Shit.